SolidWorks provides many time-saving tools and specialized functions for the mold designer. These can be found in the Mold toolbar, located here in the Command Manager. Let's start by identifying and generating the parting line. We can accomplish this in SolidWorks by using the draft analysis capability. Draft analysis allows you to interrogate the model and shows you all the positive and negative faces in relation to the draft direction or the direction of the pull for the mold. SolidWorks also features advanced analysis capabilities like undercut detection. This allows you to look at the model and understand if any undercuts will affect the cost and type of tooling you need to design. Here is an undercut that requires a slide mechanism or a side core in the injection mold design. By identifying this now, we can understand exactly how we're going to design the mold as we go through the process. We can also create additional parting lines. Now let's identify a parting line here on the side core. Notice that the propagate icon allows you to select all the single edges in a single operation. Next, using the parting line tool, we select the open area for the telescopic shutoff. Parting lines can be leveraged for multiple purposes in SolidWorks. For example, generating shutoff surfaces or identifying areas that will require a shutoff later in the design process. The Shutoff Surface tool automates the creation of surfaces, closing off all the tooling geometry. Now, let's create the parting surface, which is based on the parting line that we created. The parting surface is a surface that will split our tooling. SolidWorks provides various smoothness controls that help indicate how the surface is being created. For example, to show whether the surface is tangent or normal to the tool surfaces. These tools are invaluable for not only ensuring the manufacturability of the tool, but also for reducing the manufacturing costs. Now that we have the parting surface, we can generate the core and cavity geometry. All you need to do next is sketch the overall shape of the tool to be split. And then the core and cavity will be created automatically for you. A preview is provided, so you can quickly view the results. As you can see, we have created the coring cavity for this part. On this side of the part, we find an undercut. We'll need to make a side core. By switching to a wireframe display, you can quickly sketch geometry in order to capture and extract the side core from your design. Because everything is sketch-based in SolidWorks, you can easily and quickly create relationships to center the geometry on the side core extraction. Using the side core tool, simply drag and drop. The preview in the graphics area provides feedback that specifies exactly what size you need to make the side core. Now, we have quickly created the 3 pieces of core geometry required to generate the injection tooling. Since the tool has been segmented into 3 pieces, core, cavity, and slider, we need to turn those pieces into actual parts. SolidWorks allows you to take the pieces, save them automatically, and rename them as you're saving them into an assembly. Let's save this tool as Mold Assembly. Here is our geometry in the assembly. As we explode the assembly, you can see exactly how rapidly and easily SolidWorks extracted all the surface geometry from the cover part, creating a core, a cavity, and the slider. This provides all the geometry you need to create the injection mold tooling. When it comes to designing mold tooling, only SolidWorks provides you with such powerful, easy-to-use, and intuitive capabilities.